Hey, hey, hey! Let's talk about factoring polynomials. This is section 1.5, because I showed you last class how to multiply polynomials together, and this is the opposite of that. We're not going to learn dividing until later, but it'd be nice if I had a polynomial like, I don't know, x squared plus 6x plus 8. It'd be nice if I could break this back into the two polynomials that it's a product of. It turns out that this one is equal to x plus 2 times x plus 4. How did I know that? Well, if I multiply those, I can FOIL. First is x squared, outside is x times 4, so 4x. Inside is 2x, and last is 2 times 4, which is 6. Didoy, 8, 8, 8. 4x plus 2x is 6x, so I get x squared plus 6x plus 8. Now, I kind of pulled those two binomials out as if by magic, so I'd like to show you how to arrive at them. I'm sure you saw this in high school, but let's recall. It's easiest to factor trinomials that look like this. X squared plus bx plus c. So b and c are just going to be two unknown coefficients. They're numbers like 6 and 8, but I don't know what they are right now. Let's say that that's the form I'm in. I call this the sum product method, by the way. You'll see why in a moment. Well, do you notice over here the x's are alone? They don't have coefficients. And that's because the first term was just x times x is x squared, right? No coefficients there. If there was a coefficient on one of the x's, it would show up on this x squared. Like 2x times x would be 2x squared, and then they wouldn't match up. So if the x squared doesn't have a coefficient, in other words, the coefficient is 1, then neither of these x's in the factors can have coefficients. I'm going to call the factors x plus p and x plus q. Let's FOIL this and see what we have, okay? First, x times x is x squared. Outside is qx, inside is px, and last is p times q. Why am I doing this? So I can match up the answer with the problem. I want to match those two up, and what I've just done is, check this out, I'm going to factor out an x here. Qx plus px is the same as q plus px. Okay, the reason I did this all is that these two things are equal, so x squared matches with x squared, bx matches with q plus px, so b is q plus p, and c matches with pq, so c is q times p. That's why I call it the sum product method. The middle number is the sum of p and q, the last number is the product of p and q. So if I can come up with two numbers that add up to 6 and multiply to 8, I have my factors. Now 2 plus 4 adds up to 6. 2 times 4 is product, that's not a word. 2 times 4 makes 8. So that's why I know that these numbers are 2 and 4. So that's what I call the sum product method. It does take a little bit of creativity, what two numbers get us there, but it's not so bad. All right, let's say I have x squared minus 7x plus 6. I need two numbers that add up to negative 7 and multiply to positive 6. Take a second and think. In fact, let me write 4 of these up here. See if you can solve these. It has to add to the middle number and multiply to the last number. Go ahead and pause the video now. And welcome back. Let's see if you got them. Two numbers that add up to minus 7 and multiply to 6. I'd say those are minus 1 and minus 6. add up to 5 and multiply to negative 24. Oh, that's tricky. I'm going to say those are minus 8 and plus 3 down here. 28 is 4 times 7. If I just go by things that add up to 3, I'll be here forever. 1 plus 2, 2 plus 1, 0 plus 3, negative 1 plus 4, negative 2 plus 5, so on, so forth, so forth. There are infinitely many pairs of numbers that add up to 3. But there's only 4 that multiply to negative 28. It's either 1 and negative 28, negative 1 and 28, 4 and negative 7, or negative 4 and positive 7. And the one of those that adds up to 3 is negative 4 and positive 7. So it's faster to look at product pairs for negative 28. Is it negative 1 times 28, 1 times negative 28, 4 times negative 7, negative 4 times 7. I guess 2 and 14 would also, a 2 and a 14 would do. So I don't have to write all these out every time. I'm just looking for a pair of numbers that have a product of negative 28 that are 3 apart. If they're 3 apart, like negative 4 and 7 are, it'll work. And x squared plus 4x plus 3, saved an easy one for last. So that's slide and divide. So then if I hit you with a nasty one like x squared plus, I don't know what, 14x plus 33, you just have to think, okay, what are the actual factors of 33? It's 1, 3, 11, and 33. Can I make those add up to 14? Well, yeah, 3 and 11 add up to 14. So this is x plus 3, x plus 11. It's a lot faster to think what multiplies to 33 than it is to think what adds up to 14, is what I'm trying to say. So that is, oh, geez, what did I just call it? The sum product method. That's it. We've seen the difference of squares already. If I asked you to factor something like x squared minus 36, that would be x plus 6 times x minus 6. And these are a squared minus b squared equals a plus b, a minus b. See? Because the outside and the inside terms, when you FOIL, cancel out. We could even do something crazy like, what if I gave you 4x squared minus 25 to factor? Any ideas? Well, pretty clearly b is 5. What's a? What thing times itself is 4x squared? It's 2x. All right. So this is going to be equal to 2x plus 5 times 2x minus 5. Nice. So that's the difference of squares. Sadly, there's no way to factor sum of squares. If I have x squared plus 9, doesn't factor. Sad face. Okay, this is wild. This is real wild. What if I have a plus b? You'll see where I'm going in a second. This is weird. Let me make columns out of a squared, negative ab, and b squared, a and b. And let me show you something real wild that happens here. I'm multiplying like terms, so a times ab is a squared times b. Yeah, doesn't matter what order they go in. This is ab squared. This is ba squared. And this is negative ab squared. And this is b cubed. Well, check this out. This is wild. Check this out. B times a squared and negative a squared times b are the same number, so they cancel out. And ab squared and negative ab squared, those are the same number but opposite, so they cancel out. And we're just left with a cubed plus b cubed. This is called a sum of cubes, and once in a blue moon, it's very handy. So for example, if I asked you to factor x squared plus 8, you would write, well, oops, not x squared plus 8, that doesn't factor. That doesn't factor at all. But if I asked you to factor, oh my goodness, x cubed plus 8, well, here a is x and b is 2, so follow the formula all the way. A squared is x squared, negative ab is negative 2x, b squared is 4, and a plus b is x plus 2. So that's a nice way to factor x squared plus, or x cubed plus 8. Like I said, once in a blue moon, this comes in handy. As a matter of fact, if we switch up the signs here, a minus b times a squared plus ab plus b squared. Go ahead and make the 6 boxes for this one if you'd like. But otherwise, you could take it on faith. This really is a cubed minus b cubed. So this is a difference of cubes. And again, once in a blue moon, these two guys come in really handy. So pays off to know them. Before we go on to tougher factorizations, here's a fun number trick I like. Let's say I asked you to multiply 98 times 102 in your head, no paper, you have 5 seconds. 2, 3, 4, 9,996. How did I do it? How did I do it? I noticed that 98 was 100 minus 2, and 102 was 100 plus 2. So by difference of squares, my final answer is 100 squared minus 2 squared, which is 10,000 minus 4, which is 9,996. So if the person you're talking to doesn't know this trick, you can convince them you're a math genius by multiplying many digit numbers in your head. You have to pick the number. They can't pick the numbers. You have to secretly pick the numbers to be difference of squares or just get lucky. But once in a while, this is a really cute way to multiply numbers. It's handy, you know? So like if you asked me what's 37, like say we're doing a story problem and the width of the patio is 37 feet and the length is 43 feet and you ask what's the area and my calculator runs out of batteries. Well, I know it's 1,191 square feet because this is 40 minus 3 times 40 plus 3, which is 1,600 minus 9. Cool, no? Quick maths. All right. Okay. First thing you should do if you're trying to factor out a big old polynomial, let's say I gave you some monster like, let's say x to the 4th plus 5x cubed plus 6x squared. Something called a GCF that stands for greatest common factor. When you're trying to factor a big old polynomial, taking out a greatest common factor is great. Look, x squared goes into this term, and this term, and this term. So if I factor out an x squared times x squared is x to the 4th, x squared times 5x is 5x cubed, and x squared times 6 is 6x squared. And look, now we're left with a sum productable, that's not a word, we're left with a trinomial that we can use the sum product on. 2 and 3 add up to 5 and multiply to 6, so our final answer is x squared times x plus 2 times x plus 3. See, this x squared, don't forget, it sticks around. It doesn't do anything, but it sticks around. And this guy turns into x plus 2 times x plus 3. Oh, and look, just like I told you, a second degree times the first degree times a first degree, 2 plus 1 really is 4. That always works when you're factoring or multiplying polynomials. The degree is conserved. And that's going to be real handy later in Unit 3. So that's a factoring trick, taking out the greatest common factor. Here's another one. Let's say I gave you 3x squared plus 9x plus 6. Uh-oh. Leading coefficient is not a 1. He didn't tell us how to solve these, but there's a trick. Notice all of these terms have a 3 in them. This is the same as 3 times x squared plus 3x plus 2, yeah? 3 times 3x is 9x, 3 times 2 is 6, yeah? That's a lot better, because then I can write that that's 3 times x plus 2 times x plus 1. As 2 and 1 add up to 3 and multiply to 2. So that's how you factor that. Pretty cool, pretty cool. All right. There's one more factoring trick I want to show you for when we don't get so lucky and have a GCF. I want to show you something I like to call slide and divide. I used to teach something called factor by grouping, and I think if you read the textbook, that's what they recommend in this section. But ever since I learned slide and divide, factor by grouping just seems like way too much work. So here's how this works. Let's say I have 5x squared plus 7x minus 6. Oh, tell you what, let's break this video into 2 parts here. I'll show you slide and divide in just a minute.